Hello everybody, hopefully everyone's having a good time. So I'm going to have two parts to my talk really. So first part will be Vue.js, and we'll look at where it's come from and what it's like in the industry at the moment, how it's doing. And then we'll go into some details of how Vue works internally, how other frameworks and how they all work internally. So all of the reactivity frameworks that you use now, we'll look at how they all work from fundamental reasons. And then we'll go into service workers and then making them go real time with WebSockets. So you can use the hashtag jsday, or you can follow me on Twitter, Blake Newman, nice and simple. So, Vue. Where did Vue come from? Well, this ain't working. Wait. There we go. There we go. So it's all working now. Good. So originally it came and it was called Seed. So this was a time when Evan New was working in Google. He liked using Angular, but he felt that it could be done better. So he started to develop the framework, and it was born around July 2013. And obviously, you know, the father's Evan New. And since then, we're going to see what's happened since then. So there's 25 core team members, and those core team members speak 12 languages. So that's really cool that we're starting to grow, and Evan New's not only the only one taking control anymore. We all input, we all validate, and we all make sure that the community grows together. So now there's 50 repositories or plugins that are in NPM that are officially maintained that not just do Vue stuff, but also help the rest of the JS community. So Vue's bringing back and taking at the same time. There's over 160 backers, and it keeps on going. These are people who donate from $5 to about $5,000, and over 20 of those are companies. So there are 10 individuals sponsoring. They're already sponsoring over £50 or $50, which is really incredible that someone's actually investing $50 of their own money because they're using a tool. And that equates to over $10,000 for an ecosystem. So most of that goes to Evan, and he will go and use that for building other tools and building up conferences, etc., and going to talks to help people out. So a lot of the money helps him continue doing it full time. There are other avenues. There's one-off payments and anonymous donations. So those donations, some companies don't like putting their name against it because corporate reasons, etc., because they don't do open source, but they still do back it. It was probably one of the first financially backed frameworks, which is interesting because now you can see tools like Webpack, etc., starting to get funding, and that's what's really growing our open source community. And as those tools that are developed by individuals start getting funding, we'll see much more progression within our tool sets. It's important if you are a company or an individual and you use a tool, maybe think about giving even $1 a month or $5, because you're using a tool, you're using it for free, and that little money will go a long way once it tallies up. So in the organization itself, there's over 110,000 stars on GitHub, and it's the 14th most starred organization. And Vue itself, the core repository, is the 11th most starred repository. So that's pretty impressive over the 3 years that something that was built by someone with their own philosophy and how to do something has built something up with a team and actually feeding back into the community. And you can do it yourself. So if you have a really good idea, do not be afraid to start your own open source project. It doesn't have to be a framework. It can just be a small library that does something simple. Like Sidor Hasores, if I say his name right, he's just phenomenal. He's got way more than any contributions in the open source community. He just does it for fun. There's 800 NPM releases, and we are fast moving, but we try and keep it safe for you to use. So we follow the break-in, mine, and patch system, which is typical for open source. There's 1.6 billion npm downloads across the organization, which it's not a true metric because that includes people each time they deploy, but it shows a high volume number. So that's kind of where it's come from, and I don't want to over market it because you're not here just to see me market Vue. So we're going now into what it is. So it's not just a JavaScript framework, it's a progressive JavaScript framework, which is really interesting. So what do I mean by that? I mean by several ways it's progressive. So it's not necessarily progressive in PWA ways, but it's progressive in how you can use it. So you can use it like jQuery. So out the box, you can just include a script tag, and then you can use it as you would with jQuery. But it's not quite like jQuery because it's not jQuery. Progressively, you can upgrade your websites. So if you've got a legacy system, you can start including it and just experiment with it really easily without having to have a huge complex build tool chain. And then once you start adapting to it and you've learned how to do it, you can start implementing those build tool chains and progressively add those other libraries to make your full application, even going down to SSR and progressive web apps. Alright, so these are some features that Vue has. It just keeps on going and going and going and going and going. Now I've gone too far. So it's quite cool. Such a core framework has divulged out over such a short period of time to go and really bring in all of these tools that you'd commonly want from one library and one tool set, and they all integrate very seamlessly, which is really nice because when you use React, Router, etc., and they constantly change between React and React Router, it was very difficult to keep up to date with both those libraries because they're developed outside, one in the community, one through React itself. But Vue itself, we kind of officialize repositories and keep that tool set in-house. But there's many other libraries out there, thousands of Vue libraries. So now we'll go deep inside of how the activity system works within Vue.js. So you've got a render function. That render function, it touches properties. So you've got a disabled attribute on a button, for example, and that gets passed down as a prop. Then these are tracked through the render function, and they're touched. That then uses object.defineProperty to go and create getters and setters, which means that it'll be able to track those dependencies and then notify a watcher that something's changed within it, and then it will go and update that DOM. So in the future, we'll be looking at using ES6 proxies, but at the time being, it's not there yet. You can't polyfill it, but that means there's no caveats to using ES6 proxies, and you can do a lot more with ES6 proxies, which is a really cool feature we're looking into. So once that watcher observes it, those are notified. So that means only that component you're touching gets updated. So you don't have to say, should component update? It just does it out the box, and we'll go into more detail in a second of how that all works. So, detecting changes. So we'll kind of look at the pull and push reactivity models. So React is predominantly a pull, unless you're using MobX, which then kind of makes it into a push reactivity system. And Vue.js is a push reactivity system, and if you used to go and use immutable data structures, you're making it a pull system. So we'll look at the differences. So if this is our component tree, don't know how well you can see all the lines, but let's say the top node, we go and that's the component's changed. That's the button where our prop has changed in our data set. So that means something needs to change in that component. It needs to patch the DOM and rediff, or diff, then patch the DOM. So traditionally, if you had no way to monitor and where it comes from, your whole tree would update because the page doesn't know where things are happening, so it just goes and changes the whole tree. So with React, what you'd do is that black circle you're basically saying should update. So you're telling React when it should update and whether that data means something to that set tree of components. So you'd maybe put it on that branch or that component, and then it would stop the other tree from updating. But you'd want to keep on doing it across all components until it gets to that component. And you just naturally do that as a developer, but it's quite a lot of boilerplate to go and do. So that's what you want to end up with. But the difference between React is that all of the data gets pulled, so you're basically pulling the tree to find out what needs to change and whether you should update. And what Vue does is basically you have a push system. So you push changes, and it goes down the tree, and then once it's detected that dependency and it's been tracked, it will then go and update just that single component, so you get that real performance benefit without having to do anything really. It all comes out of the box for you, and that's really done through the templating system. And then you can do other stuff within JSX, etc., that really makes it powerful. And we'll go into more differences between templates and JSX in a minute. So another cool thing within Vue is that, say you had a top level component and you had a static node which is just static text, then it doesn't need to track anything. So that branch just keeps as it is. You don't have to go and re-update that, and you don't have to go and do anything about, oh, this is a cached component. You don't have to go and really statically analyze anything. It does it for you. So there's another cool feature before I go into how templates and JSX differ, and I've got a little demo for you. So you've got a single file component. So it's a tool set upon Vue, so you don't have to go and use it this way, but when you do, you get lots of benefits. For example, you get pre-processing, post-processing, transpiling, linting, automatic hot reloading. So that means when your component, you change it, rather than it reloading the whole page and rebundling everything, it knows that that's the only file you've changed. It will go and patch and send that across, and only that component gets rehydrated with its state, and it will reload just that component, which is really useful and makes development much quicker. And you can do stuff with React, etc., but this just comes out of the box with a Vue component. You can have CSS modules, scope CSS, and much, much more. You can the point of this file is you're keeping the concerns of a component together, but you're keeping it divided. So you can also use render functions, etc. So you don't have to be stuck with a template. So if you've got a very low-level component, you can still use render functions in JSX to do that very complicated component, because templates don't achieve everything. So as I said, you can use JSX or render functions or templates. But why templates? Let's see if I can zoom in a bit. There we go. So essentially, this is just showing you what happens with a template. So a lot of people forget is that JSX and templates compile down to the same thing. It just compounds into virtual DOM representation, which is just plain objects. So JSX is developed to be declarative. So you use it to make your JavaScript more declarative, and it makes your life easier to understand your component. Templates do the same thing. It's just a different way of working around it. But there's some fundamental differences. Neither are the best way. You can use them how you like, but neither one is predominantly better. But there are some differences, so we'll go through that as I go through the demo. So first thing what we'll do is we'll create a for loop, so you can see how that render function gets created with a for loop. So one thing you might have noticed that there's a with statement. Don't put that in your JavaScript code anywhere normally, but this is just a power of leverage of templates, because you don't have to provide context to your template. Then you're wrapping that whole context within that this statement. So as you can see, anything in this, if I was to use message, which is here, you don't need to do this dot, so you don't need any compilation step at runtime, so it makes life easier for you. But at build time, we strip the with, so you get a nicer JavaScript which is better and not depreciated for one. So let's break this down and create a for loop. Really difficult typing on a different screen. So put that in a span, and then you have directives in Vue for your templates. So it's kind of similar to Angular, but none of your ng tags stay on a DOM. It's all removed when it gets rendered, because we can do that at compile time. So let's just say item in items. So over here, you can still see that the code that's generated isn't imperative anymore. It's declarative. So there's no real logic in here. It's still just using helper functions that are internal to Vue. So you've got no worry that that code will ever change across different components. It's always declarative within that style of coding. So for example, you see you've got the VM, and then you've got a helper function, which just means a list. And then for the items, we just iterate over that, and then for each one, we just return that virtual DOM nodes, and that just brings out an object of a virtual DOM representation, which would then be used to patch the DOM or diff and patch the DOM. So one of the cool things about this is that we're able to do some static analyzing on the template. So at compile time, you get a few benefits that you'll never get with JSX, which you can do with JSX, but you have to manually intervene and do it yourself. So for example, if I was then put a p tag after this template and just put static content, wrap that again in a span. So you notice there's this m helper function, but there's nothing been passed in here. You can't see the static content text there. So what's happening there is that we can statically hoist those static nodes. So if you've got a page of content, you're no longer going to have to patch or diff that. That's just cached for you. So with JSX, you'd have to go and implement all of these caching techniques to go and cache those individual DOM nodes that you want to cache, because it's just static, which is a pain in the ass. So also, there's another thing. We can normalize our children. I can't show you this within the demo, but essentially, normalization of an array of children is very expensive, and you have to do that at runtime. And this happens within React and Vue.js. But we can further ignore these during compile time, because we can statically analyze and determine whether that loop has any static nodes within that. So you don't need to go and run further down the chain, and you can normalize at a higher level. So we can go and detect that, which is really cool and only possible with templates. If anyone has any questions about how Vue works even more in depth, I'm happy to talk about it with you in person or on Twitter, or you can just go read the docs. The docs are beautiful for just going and understanding how reactivity systems work, how template systems work within modern JavaScript frameworks. So you don't have to go and learn Vue.js itself and go and develop with Vue.js, but the documentation there would actually help you as a long run as a developer to go and learn something new, because there'll be other frameworks that adopt these kind of principles as they go along. So this is kind of the Vue.js part, which I didn't want to go too much in depth because there's so much great resource out there for you now. So what I'll go on to now is just quickly talk about, let's go back onto here, is the VueConf. So if you really want to go and learn more about Vue.js, there's a new conference, and it's the first worldwide conference at Vue.js, and it's going to be really awesome. It's in Wrocław in Poland, June the 21st to 23rd. There's some really awesome speakers that aren't just talking about Vue.js. So you've got Sarah Jasner, which is a prolific developer who stands out with everyone with SVGs and animations. So if you want to go and learn how to create cool SVGs and animate your website, that's a great talk to go to. Then you've got Sean Larkin, which he's a Webpack guy. And there's awesome talks and more to come. There's also 8-hour-long workshops, myself, Evan Yu, and Sarah Jasner once again. I'm just going to skip over this because you can go look it up on the web, but there's the website, there's the Twitter, and there's the support email. There's a lot of cool after-party events as well if you want to come along. But now I'm going to go into something that I think is really cool, and that's making service workers go in real time. So essentially what we want to do in our modern service workers is to extend that features with other technologies we've already got in our tool chain. But some of them you can't directly access because service workers run in the background, so it makes it hard to go and use. So you have to sometimes re-engineer and rework out how you can use these technologies together. So let's look at what a service worker is. It's a background service that handles network requests and intercepts them. So you can have offline situations, caching, background syncs, interval syncs, push notifications, for example, and they're generally useful for one-off client-to-server communications and doing something with that interception. Then you've got web workers. It's good to know not to get confused between the two. So web workers essentially just mimic multi-threading, and they're intensive scripts that run So you've got intensive scripts and you run them in the background so they don't block the UI, etc. So maybe you'd have network requests going there, but service workers have their own purpose and workers have their own purpose. So a service worker intercepts traffic from a client. And as we can see there, we've got a server, a client, and a service worker, and cache. So our client will go and make a network request. The service worker will go and intercept that, which at that point, it goes to the server because we've got nothing in our cache. And then it will bring it back to the service worker, which will then save it to the cache, and then pass it back to the client. So next time, when we're offline, we might be able to get it from the cache. Let's look at what WebSockets are. So they're an open connection between the server and the client. They're a full duplex system for sending through data. They're persistent, and they're great for creating a real-time application. That's what you use them for, predominantly. So this is what our server, WebSocket, and client looks like. Simple as you just have a WebSocket which it's just sending through data. And then if you went offline, you'd have nothing because it doesn't support offline. So we want to go and combine these two because we can create really powerful applications if we could go and do that. So you'd have your real-time application still working offline just with that cache copy. But the problem is, when you go and put them together, you can't use them together. WebSockets are a single persistent connection, which means service workers can't go and intercept that because there's no fetch request going through. So I originally tried to plug it into service workers and it just doesn't work, and I had to go and think how to go and do that. So, what the fuck? Help, what do I do now? How do I get it to work? Right, so you try alternatives. Background sync. It's good, but it's only for you can only do it on a certain event, for example, or you can use interval sync, but they're not really supported, and interval sync is just basically like another Ajax polling system that you just set the time. XHR polling, yuck, don't do that. And then there's also another viable alternative. You can use server-sent events, which is in HTTP2, but they're not full duplex, so you can't do the reverse communication on that single connection point. They're a viable solution for simple data flow. For example, if you've got a Twitter page and you've got just a stream of messages coming through, perfect. That will make your real-time application work. And then you can actually go and intercept them because they're a normal HTTP request. So what we really want to do is get a client to server messaging system. And that's what we use WebSockets for, is abstracting it away from its predominant use case of sending through data and make it more versatile in terms of it will just become a messaging system, which then we can just do normal HTTP requests and they're cacheable. So we'll look at how we can integrate them and actually do a bit of code example. So we have a server, the WebSocket, service worker, and client and cache. So essentially, we want to create a full duplex messaging system, server to client, which you could also reply back to confirm that that message was received and then send back another message, for example. So it gives you more control. The server broadcasts simple messages to the WebSocket, which will come down to the client. And then what we would want to do is act upon and react to that message and then just do a normal GET request. So let's look at how that would work. So the server sends something through the WebSocket. The client receives that message. We then do a normal GET request, which will go to the server and then bring us back down to the service worker, which we can cache, and it gets back to the client. So you're basically using this as an optional layer. We want to use this progressively. And then if we went offline, voila, we still have our cache copy. So this is a little demo of something I worked on in Sainsbury's. The data's skewed, so you don't know actually anything about our products. But essentially, this is an online collaboration tool where a team of people from different parts of the business will go and model prices. But because they want to go and collaborate as teams to work and in meetings, etc., to go and do that, they'll be on multiple machines. Before, they're just using Excel spreadsheets, which you can't really go and collaborate on. So what we did with this, we enabled collaboration with this real-time feedback. So what we'll do is on this screen, we'll change the price. £1.2. Then submit. Damn, I'm offline. No, it's because I need authentication for this and I've probably logged out. So essentially what would happen is that that screen would then update with all of that data, and that's just using that same system we've used. I'll actually do some demos of it in terms of what it could be useful for. So if you've ever been on, what was I going to say? For example, Amazon, and you're in a basket, you have 2 tabs open, 3 tabs open, 4 tabs open, because you're trying to find the best product for you. You close one tab after you've added it to the basket, you add something else into your basket, you look at another tab, you've got nothing in your basket. That itself is annoying for users that don't predominantly use the web. For us, we understand it's because we've had multiple tabs open, but someone else who's got a mobile device and then they're using their laptop to actually go and do the purchase, they're not going to understand because they've left that page open. It should be updated, surely. And then they'd have to do a refresh. But a lot of these older generation that only just come into computers don't understand that you have to refresh to get your data back. So what you can do is you may be able to add that WebSocket layer to then just feed that data to go and refresh the page without the user intervention. So what we'll do now is we'll look at the service worker and how we can cache that, all of those requests. So we'll add an event listener. So we'll go through this line by line, and so you can understand how you'd create this service worker. And it's not a full service worker, it's just for that simple task of caching requests. So we have a fetch event. Hopefully everyone can see that all right. Thumbs up, hands up if you can't. Yeah, it's good. So we get that request object and we get that URL from that request. If it's not a GET request, then we don't really need to cache it because a POST request might bring back alternative data each time you post it because it might have side effects. And if it's from a different origin, so say it's analytics, you don't want to cache that either because you're never going to be sending back that correct data and receiving that data correctly again. So what we want to do, after we've validated that this is the request we want to cache, what we'll do is we'll respond with, so I'm using async and await, so sorry if people haven't used it or don't know what it is, but essentially it's just a wrapper for promises. So everything that gets returned from it will be a promise. So we have our try catch block. So we'll try make that request. So if the navigation is not online and it's in the cache, we'll return the cache. If not, we don't have anything, so it's not going to work. But if we are online, we're going to want to go through that normal process of sending off that request. So we'll fetch that request, and then basically we're waiting for that request to resolve, which is a promise, and that gets put into the response. If the response is not okay, then we don't want to cache it. We just want to turn it back to the client because we don't want to cache error messages. And then if it was okay, we want to respond to that. We want to place that in a cache. So we'll open up the cache, and then we'll just put that cache in there. And then we'll just return the response so the client gets that response as well. So next time you come to it, instead of going to this layer, you would go to this layer and it would cache if you're not online. And if there is an error, it might be because we're on a landing page or something, so we'll do some special stuff there. So that's essentially what you'd have for your service worker, just to cache those requests. And that's what you'd generally implement as a normal service worker. I'm not doing anything special there. Then we want to look at how we can get that server and WebSocket messaging system created. And for this example, it's going to be a little bit naive because I don't want to overcomplicate your minds. But we'll create a little Express app, and we'll have our server messaging system from there. And then, voila, we would have part 2 done. So go back down. Right, so essentially, we create our Express app. We use socket.io as well because it's just simpler to go and explain in this talk. So we have a post request. On that post request, we would emit that event. So that event will now get broadcasted to the client. We can do other stuff to limit the scope of that. So we would also have a GET request, which is just where we get our general data from. So we don't want to be transferring that data through the socket anymore because we want to be able to cache that. So on a normal GET request, we get the data instead. And what does that introduce? That means your sockets are now completely stateless. You're not actually got data being stored somewhere, you're just using it for a messaging queue, which means you're leveraging a very powerful tool for something simple that will really improve your UX of your website. So that was it for your services. You can obviously, you're going to add more to it as you go along, but now we'll need to get that WebSocket to the client. So that is as simple as we'd have our socket connection on the client, so we use socket.io's client version, and then on the connect we can also use this because sockets are more reliable for determining whether you're online or offline for the browser, because the browser APIs are a little iffy. They sometimes only respond when you go offline by turning off the Wi-Fi, which isn't really useful because they might drop out on Wi-Fi signal, but this will actually tell us that the connection's completely lost from the server because that full duplex communication has been lost. So on connect we can dispatch that to a store, for example, and that would just probably put a state in your object saying I'm now offline, which then you can go and use on the UI. And then, or the same for when it's disconnected, offline, I'll go and do it, and then connect, it will take that off, so then it will just display a notification that you're back online or something. So for our case, we had that user count updated event getting dispatched to the client, and then what we do is we just dispatch the store, which will just handle that GET request and put that back to the state if we want, or it can just do an API call to refetch that data. However you want to use it is up to your web application, and this is quite agnostic to any tool set you're going to use. And then because we want to make this progressive, which is a really cool idea, is that your website will still work if you break your socket communication layer, because you're still using HTTP for your rest of your application. We're just using that socket layer to refetch data. So I'm receiving that message. If applicable, we'll dispatch events to the store, and the store will handle that API. We detect that mobile connection to the server, and it's more reliable. And you can still combine both. So you can still use that browser API and this API to go and determine. And in the application entry points, that would be your entry point, your async loader socket layer, and then the service worker layer as well. And then that's essentially all you need to do to build that really cool layer to give extra feedback to your user. So it's a bit of a naive implementation, and we can further extend that very easily. You're just going to send more messages, create some rooms to go and communicate across. It can only broadcast to messages that are relevant to the client, for example, and because you're not going to want to react on everyone's updating of they've updated their basket. You don't want everyone to go and refetch their basket, so you need to pay that into attention. What we have done though is we've proved that APIs can coexist with each other. You don't have to just use service workers and forget about the other technologies out there. You can combine them and use them in a new manner. We can improve our interface dramatically. Just by some 50 lines of code, you've now got a real-time interface, which is not fully real-time because that network request for your GET might fail, but you're still getting that feed of information, and your application should update. We can make it more intuitive as well without complicating. We don't have to have a refresh button on our UI to say, go refresh this data, something's changed. We can just auto-retrieve that data. And it provides real-time progressively. So I call this a PRA, a progressive real-time application. Real-time communication while still supporting standard HTTP. And if it fails, we just use the HTTP. And if we've got that connection to this client real-time, we can go and use that. So what I'll do is I'll go back to that example so you can see how it works, and hopefully I can get it working. So if I refresh it, the blank page somewhere. There we go. So hopefully it will load up this time. Probably next door using all the internet. Let me just open up the local host, check the server so up and running. It is. Why you know work. Right, we can still do it, but I just won't use the presentation to do it. It's probably because it's in an iframe. So split these tabs. Come on. Really hard working backwards. If you ever try it, don't do it, because it's not fun. Right, so we're going to the scenario. Click package food, blah blah blah. So all of this product data is fake, so you're not going to learn any secrets of Sainsbury's. Right, so we have our list of products there, so if I copy that over to here. So these are separate tabs. Essentially, this could be another person's device. It could be someone else who's logged in. So I want to go and change the price of this product and model a new price. So by using this, I can also show you the DevTools now, which should make it better. Right, so essentially, socket, can't see the screen. Cool. That's saying. Yeah, never mind. Something's not going right. Right, let's just try it anyway. So this is in middle of development, so I may have a few bugs. So, for example, hopefully this will work. No, it won't. Damn you. Everything's up and running. Close it down. Actually, let's turn off the Wi-Fi. Let's see if it's the network blocking it. Just wait for my Webpack server to start, and then I'll demo it back in a presentation, because I know it works. I'm not one to quit, by the way, as you've noticed. I will get it working. Right. Looks like everything's almost ready. Just waiting for the Docker container to run. It's in the fake data. Right. Looks like it should be ready. Go on. Load. Nope, never mind. I can't get it working. But if anyone wants to have a quick demo, see how it works, I'm happy to sit downstairs and give you a quick demo at some point today, because I can get it working. It's probably just I've broken something, because I was fixing something earlier today. But I hope you enjoyed the talk. Let me skip to the end so you can get the feedback link. Give me some feedback, and hopefully I can improve it, because I've got to do this talk elsewhere. So any feedback would be greatly appreciated. And anything you think I could have spoken about more, that would be great as well. So if you wanted to hear more about Vue.js and that internal structure, maybe I could strategize that better, for example.